So, traditional applications from where basically AI started its journey, by the way. From application point of view, you can say mostly it was used in gaming, right. Then puzzle solving, right. You might be knowing the first row, last column image. Do you know? So, anyone knows this puzzle? I think you know that you have a man, you have a goat, you have a cabbage, lion. They are standing at a bank of a river. You have a boat. You have to cross the river. Right? There are constraints like if goat is left with lion, so lion will, right. If you put goat with cabbage, right. So एक तो नहीं बचेगा, right. So now the task is to have to cross the man has to basically cross the river with all its belongings in some sense. You have a single boat. Boat has certain capacity, like knapsack problem you have, right. You have a capacity. So only two things the person or the man can carry on that boat. Two things. So you can change the problem differently. So you can make little relaxed constraint. You can make it little tight, right. So as you want, you can make different puzzles based on the complexity, or you can say the learner or solver that have. So this is one of the puzzle that you can try to solve using AI. So can you use AI like human, basically as a human what we do? So whenever puzzles come to us, we try to think. So what might be the path? How can we basically solve this problem? Right. So the similar ways, the similar heuristic that as a human we find. So similar heuristic algorithm we put in the machine code or in the algorithm, so that these type of problems, like we call it constraint satisfaction problem. So we want to basically, satisfaction is basically you have to solve the problem, you need solution, but at the same time if you say the constraints must be satisfied. So it means that solution what you are getting, so it should satisfy a certain constraint, right. For example, you have the second one, you can see the Rubik cube, right. So this is a very popular game, and I think almost everyone have basically in some sense we have played in some sense, right. So as a time pass, right, and it is not very easy to solve. If you don't know certain tricks or heuristic, you cannot solve. So if you provide those heuristics, those tricks to your algorithms, so mathematically you just provide it, then you can have a Rubik cube solver, right. And nowadays we have a device, Rubik cube solver device. You just deassemble, or you can say unassembled or scrambled cube, just give it to that device, it hold that cube and it will solve the problem, and that heuristic you can design. So you can put in the algorithm. So that is nowadays available as a product, as a device. First one is the basically dice game, right. So this is the very popular Ludo, right, Ludo game. And nowadays you can say that you have app for that, you can put on iPad, mobile, you can just play that game. Snake ladder. Right. So can you say that can you design the algorithms, can you design the intelligent approaches, or you can say some approach to algorithm, so that one opponent might be the computer. Right. So you can see that in the modern day, the success story of AI basically comes from the successful basically you can say the game in the game only, right. So IBM Watson, you might have heard the name. So Jeopardy game was played in 2013, I think 2012-13. So Jeopardy was won by the computer, right. So they have expert game player, and Jeopardy computer wins that game. So you can say Watson basically won that game. And earlier to that, in early 2000, you can say chess game was there, and the computer wins that game. The AI heuristic algorithm basically wins that game against the Russian player, I think chess player Kasparov, right. So then people think that the capability of AI, so AI can do many things at that time. So people started funding the AI industry. Earlier it has basically AI faces winter season, so where people say that okay, AI will not do much thing, but later on based on this gaming only, so they say that a lot of basically game which were basically played by the expert players, and computer is basically winning, computer is the winner against those players. So they thought that we can put lot of intelligence, lot of things, heuristic approaches to the machine. You can develop algorithm, you can, if you have computation, then you can do lot of things there. People started funding, and nowadays the current state of art everyone knows, right here. Another one is you can see that n queen problem, right. So here we have 8 queen problem. So you have a board of 8 cross 8 cells. You have 8 queens here. You have to place the queens on the board such that it satisfies certain constraint. And constraint is designed by the game host, right. So the standard constraint set is that no 2 queens are attacking each other. They should not be in same row. No 2 queens should be in same column, or they should not be in diagonal, right. If you want to relax this constraint, you can relax. So as a game host, you can design the constraint, right. So it is not fixed that this will always. This is a standard constraint set, but you can either you can make it more tight, either you can relax it. Maybe you can put obstacles here on the board. You say that these particular cells are not allowed, right. So many things you can just do with this. You can put the constraint. So and you have to come up with the heuristic, come up with the algorithm which can basically solve this type of puzzles. These are called constraint satisfaction problems, CSP problems. So AI basically started to solve these problems in the earlier days. This is one of the problem, map coloring problem. So map coloring, you can call it region coloring. So given a map, no 2 adjacent cities or regions should get same color, and you have a constraint on the number of colors. You say that okay, you have only 2 possible colors to use, 3 colors, 4 colors. Like that, you have a constraint on the number of colors, and the problem is that no 2 adjacent regions should have the same color, right. So this is again the constraint satisfaction problem. So you can say that any solution which satisfies this constraint, right, is solution for you. Now the question comes that how fast you are doing this, right. So when we talk about the algorithms approaches, the complexity comes into picture. So how fast your algorithm, how efficient your algorithm is. So how much time it basically requires to solve the problem, to solve this CSP, constraint satisfaction problem. The same is true for all the algorithms that we have. So we have time complexity. If you have studied data structure, you have studied algorithm course, then you know that every algorithm we want to basically assess with respect to its time, how much time when you implement the computer will take, how much memory it will take during the computation. We call it memory, right, space complexity. In AI, we use 2 more things in addition to time and space complexity, because problems are not deterministic, right. We are using heuristic. So we will see that how good solution is, the quality of the solution. So if your approach is deterministic, so quality is already ensured. So what if I say that you want to get optimal solution for shortest path, you apply Dijkstra algorithm or any deterministic algorithm which gives the shortest path. So if you say that this path is shortest, it means that there is no other path, or you can say so there is no way to get a better path than that, because you already said this is the shortest path. You might get alternate, but the path length will be same, right. If you say that this path is 5 kilometers, shortest path, smallest route is 5 kilometers. So when you say smallest route, so it means that no other route exists that has less than that, right. So, but suppose I say that you are having many paths of the same shortest length. So, which one is good for you? So, here heuristics comes into picture. So, the approach, the heuristic, the algorithm that you have, heuristic algorithm, which gives a good solution for you. So, that is why I conveyed my story, yesterday's story. So, we had two paths, distance was similar, right, maybe 2-3 kilometers, the time was little similar, but I have chosen little longer path because of the heuristic. So, that tells about the goodness. So, how good solution is, we call it quality, right. So, time and space, then we have quality of the solution. So, how will you ensure the quality of the solution? So, that is another criteria we will discuss with all the algorithm in AI. Then the fourth one is correctness, you can say. If you have AI algorithm, because we are using heuristic, it might not give you the solution. So, many times the algorithm, because it is not deterministic fully, we are using heuristics. So, heuristic might work and sometimes it might not work, it may not work, right. So, that is why we have to assess that if solution exists, then whether the algorithm is capable of basically getting that solution or not. We call it completeness. So, another criteria that we have to assess with AI algorithm is completeness, where your AI algorithm, your heuristic is complete or not, right. Complete means, suppose I say that we have to reach from one place to other place, we have certain heuristic, based on that heuristic we chosen the path, but we never reach to the destination. Suppose we choose certain path and we never reach, then your algorithm, your approach, your heuristic is not complete, right. Even solution exists, even there are path, but we are not able to reach, we are not able to get the solution. So, these two additional parameters we have to use: optimality, that we call quality of the solution, whether whatever solution using your heuristic you have found is optimal or not, we call it quality, and another one is completeness, right. Whether if solution exists, if solution does not exist, then of course none of the algorithm will be able to find it, but if solution exists, whether our algorithm is able to find the solution or not, if it is so, you can say your algorithm is complete. So, we will try to compare the algorithms in AI on 4 parameters: time, space, optimality and completeness. So, whenever we have any optimization algorithm, right, so you have to tell these 4 things. Okay. Then after this puzzle solving, constraint satisfaction. So, if you say that okay, we want a best solution, so we have many solutions which satisfy the constraint. So, out of many solutions, if you say that we are interested in finding the best solution, right, you might have many solutions which satisfy the constraint. For example, in 8 queen, so you might have many arrangements of this placement, but if I say that which one is best, so if our task is to see that which one is the best, so this is called a constraint, the same problem is called as constraint optimization problem. What we call it? COP. So, earlier we called constraint satisfaction. Our aim is to just satisfy the constraint, whatever solution we will get, okay, we signal that we have got the solution. But when I say that no, we have to solve the constraint optimization problem, it means that you might have many solutions which satisfy the constraint, but we want the better one, best one. That is constraint optimization problem. So, we use heuristic algorithm where we are not able to do the deterministic optimization, or they are not feasible, then we have to use heuristic optimizations. And there are many problems where we use heuristic optimization algorithms. So, that is why this AI area now it is broad, right. So, many problems we try to solve, many optimization problem, many constraint problem we are trying to solve. Even our modern day machine learning algorithms, generative AI algorithms, deep learning algorithms that you have, so they all are COPs. Right. We have certain constraint, right. We have to get the best solution, we have to optimize it. Right. So, if you get one solution, it is just you have satisfied the constraint, but our aim is to find the best solution. That is why we have optimization. So, one whole day is dedicated on optimization. We have a different type of optimization algorithms, right, starting from primal dual conversion, right. So, most of the traditional machine learning algorithm, geometrical machine learning algorithm like linear regression, where we try to minimize the mean squared error, right, logistic regression, where we try to minimize the boundary cross entropy, neural network, you can say mean squared error, boundary, or you can say cross entropy loss functions, or in support vector machine. Many of you might have heard the name support vector machine, SVM, right. So, it has also very good history, right, support vector machine, and many tree based classifiers. So, we have certain objective to fulfill, certain objective to optimize, right. So, those form of objective functions we will see here in the next session, very next day, tomorrow, and we will try to see that what are the approaches available to solve those optimization objective functions, right. Then that will build a story about the optimization algorithm, we will discuss the optimization algorithm. So, neural network uses basically gradient descent based approaches, to basically learn the model, learn the parameters. Right. We will discuss more in theory, right, what are the parameters and what are the steps, maybe in the next session when we do deep study in the optimization. When we will take a problem, we will make the objective function formally and we will try to solve that. Then we have some visualization also, right. So, any problem that we have, so we try to basically represent in the vector space. So, once you have a problem mapped into the vector space, in vector space we are looking for certain object, certain boundaries, certain things, which basically separates the data points, the samples into different categories. If we have a classification problem, we try to fit certain functions, certain nonlinear, or you can say some certain hypothesis when it is a regression problem. For other problems, we have a similar nature, similar kind of things. So, we will discuss, we will try to map you. So, at any point of time, if you have any question, please ask the question. So, we want to make the sessions more interactive, more discussion oriented rather than just in teaching mode, because many things you will get online. So, lot of material is available on net nowadays. So, I think knowledge is everywhere, you can say knowledge is on internet, but many questions you might have in your mind. So, suppose some student takes the data for spam classification, right, you have his email data and you have to develop a model. So, the first questions come to your mind, so which model should we choose, and prior to that you should know that what type of pre-processing technique we want, so that our data comes basically transformed into usable form. So, mostly in vector, or you can say tabular form, or it can be represented in vector spaces, right. So, that thing then later on which algorithm you have to choose. So, those decision making, so we will try, you just ask the question, so we will try to discuss that thing, right. That is why I am just always saying that you might be knowing, right. So, many of you, I am sure that you people have done lot of solved lot of applications in AI. Even you have not solved, you have used them, right, like in chat GPT. So, many times you are in doubt, so what type of question we can ask, that might be one of the query, right. So, might be you are interested that what are the basically domains from which we chat GPT will able to answer, right. So, even lot of things you can just ask. So, whenever we are just covering the topic where we are doing discussion, please ask the questions, right. And after today's session, I think we will do certain demonstration. You might have certain basically curiosity or questions in mind, why this is happening, why this is not happening. So, maybe tomorrow onwards we expect mostly the interaction oriented session. We will just show the slides, but we do the discussion, right. So, then of course, later on probabilistic. So, probabilistic models are very old, and even from ancient days, right, we are using the probabilities, right, with past experiences. So, we might have a more confidence. If you do not have any past experience, we try to do random things initially, then later on we keep on learning. Right. So, how the human basically learns? So, you might be knowing reinforcement learning, you might have heard, right, reinforcement learning. So, that is called adaptive learning. So, that is learning by doing, right. So, you just perform any random step, right, then get the response. Based on the response, if that response is somehow you sense it is good, you are in the direction of the solution, direction of the destination, you just follow that. Mathematically, you can say you can put some reward. If you see that no, you have made a wrong step, you have to incur certain loss. Mathematically, we call it penalty, right. So, you have a reward and penalty, right. So, based on that, we try to learn. So, if you want to make basically adaptive model, adaptive learning system, so you have to follow this strategy. So, reinforcement learning strategy. So, modern ChatGPT basically uses that, right. So, the personalization that is happening in your window. So, if you say that you are a student of this year and you work in this domain, then later on you ask the question, perform the query on ChatGPT or these basically LLMs, large language models, their response is different. If you just ask a random query, you will get different response, but if you say that you just provide certain context, that who are you and what about you want to ask, then you perform the query, you will get different answer. So, that basically certain local you can say session that you have in your login. So, it basically try to learn the kinds your basically context, and that is done through RL, reinforcement learning. It do little tweaking on the cloud, so it has a certain thing there and it respond to. So, RL is very important course, so many times it is not in most of the curriculum. So, but you can just learn on online, by the way. So, probabilistic models were the initial model where you say that you have a data, you just compute the probabilities, and most of the conditional probabilities we are using. If this happened, then that happens. So, you say that okay, if future values, suppose you have a data, right, you say that if future value is this, then the probability of assigning it to a class 1 or class 2 or class 3 is this. So, based on the maximum probability, you can assign the class. You have many classes, you use the maximum probability steps. The same thing we are using in neural networks. So, if you say that your problem is a classification problem, categorization problem, where given an input, you want to basically classify into certain category or you want to assign certain category, discrete category, we generally use softmax layer, and softmax layer is basically you can say somehow you can map it to the probability representation, right. So, based on the maximum value of the softmax that you have, so you can we generally assign the class. So, that was the probabilistic models, and these were the generative model as well. They say that okay, data is basically generated from certain distributions, maybe Gaussian, instead of data you can call it features, maybe uniform distribution, maybe certain other probabilistic distributions. Maybe we will discuss it in adversarial neural network when we discuss, because we have to discuss the attack spaces. So, it's yeah, please. Yes. Yes, yes, yes. Yeah. Yeah, this is a very intuitive and basically a question, right? So, you might not have a direct response to this, by the way. So, the reason is I am just telling you, whenever we are giving anything, any query on any prompt, right? So, cloud based prompt, for example, ChatGPT. So, whatever data you are giving as input, so that is sync on the cloud. So, they are collecting the data. Even all of the apps that we have on our handheld devices, IoT devices, right? So, whatever we are doing on internet, right, your data is captured. Even you are crawling a website, you are looking for some product. So, your clicks, your crawling mechanism, everything is recorded on some of the systems, right. So, you can say some of the cloud based storage systems. Google Gemini, ChatGPT, DeepSeek, so they all are doing the same thing, they are collecting your data. So, the privacy in that term, so people are doing research, so this is a very hot topic you just initiated, and we will try to get answer maybe in coming days, 3-4 days when we discuss here. People try to work on encrypted models, so where you can encrypt your data. The training might be done, the query might you encrypt in your some encryption approach you might have that might not be decoded by those cloud systems, but at the same time you want response, correct response. So, in that direction people are working, lot of countries are working, right, to train the model on encrypted data, right. And one of the basically popular and successful model is not, you cannot say successful because it is attacked, right. So, people have attacked, and so that is homomorphic encryption based, because homomorphic encryption you can reverse it very easily, right. So, your data is encrypted, you can train model on encrypted data, you can get encrypted output, and once output reaches to you, response reaches to you, you can decode it, you can decrypt it. But this process is very costly and challenging, right. Costly in terms of the encryption, then training on encrypted data and so on. Another thing is anonymity. Many times, so the data that we have, medical data and medical records, so where the data privacy comes, right, patient privacy comes, people try to anonymize the data. So, they basically hide the address information, they hide the name information, right. Many times they basically hide the region specific information, then they send the data on the cloud for the training and for the research purpose. In this direction, one more basically development is federated learning, you might have heard the name. So, the idea of federated learning is to ensure the data privacy only because none of the industry, none of the medical organization want to basically share their data to any third party, right, to train the model. So, what the third party doing? So, they basically share their model architecture, their model, and they say that okay, you train in your company, in your local basically place on your own data, then that model you just send to me. So, in the model the idea is that you do not have data. In that way they try to convince the client, and then you have to basically upload that model to their server, and then they have such multiple models. They try to come up with the aggregation of those models. There are various techniques to aggregate the federated learning models to come up with a global or generic model. But here there are challenges. Adversary can be anyone. So, adversary might be the industry or the third party who is sharing the model and saying that please train your data on my model. So, suppose I am a malicious industry, I shared you the model. So, in addition to training, it stores the data. Maybe I will try to just give you one maybe example. So, where you can have a simple neural network model, you can put few neurons which just store the data, because they are not giving you the model to basically tweak the model, that is black box to you. Only the thing is you can train it. So, they put the Trojan, or you can say Trojan network or Trojan module in your in their software. You just train your data is there. Even one sample if they store, they know that what kind of data you have used to train the model. That is a challenge. Another is they gave model to you, you just put the bad data, corrupted data or adversarial data to train their model. So, when they try to aggregate, so because one model is basically malware, you can say malicious, yeah, yes. So, they can harm your global server, right. So, that is a challenge with the GPTs. So, if they allow the fine tuning, right, at user end, client end. So, you know that there are a lot of industries, right, they can ruin their model within a day, right. They have huge compute power, they can just flood the lot of data and they can just change the model. So, that is the challenge. That is why people are working in that area. So, if you have your some idea, some model in your mind, so that is good. So, encryption algorithm is the only hope, but the challenge is the complexity. It is a very time consuming process. We want a machine, we want a system which is real time, right. That is a human nature. So, earlier days we were little lagged. So, if you start the computer, it was taking around 5 to 10 minutes to start, but nowadays if it takes 5 to 10 minutes, we try to discard that system, right. We want that once we click it on it, it should give us response immediately. So, RTOS is very real time systems, we are interested in real time responses, right. So, that is the basically market strategy nowadays. If your model is giving you the real time response, of course, people will buy it, otherwise not, right. So, that is a very important question. So, data privacy, maybe you can come up with some idea, you can come up with a good article and some good venue. I hope that somehow we gave the, so we posed the problem only, so we have not given the solution. So, we just pose the same problem that he asked in a different way. So, we will try to see that how can we do it, right. So, then tree based classifier, right, geometry classifier like superconductor machine you have, and this one was the neural network, you can say the first neuron that Coolidge and Pitts basically published in 1960 conference, right, Dartmouth conference, I think it was there. And this is the current state of art. So, here you have a army of drones, right. You can say that you have weapons, AI enabled, or you can say AI enabled system. So, you can use in defense and other places. You can use for positive things for society welfare, you can say, you can do in transportations, you can use AI enabled drones in during the disaster management. For example, some rural place, or you can say some terrain, you have some disaster, you can send these things to monitor the things to save lives, right. So, lot of things here there. So, you can do for the society. One of the popular AI solution, or you can say AI uses for the society is the machine translation. So, machine translation is very useful for the visitors. If you are a frequent visitor, we are roaming in multiple countries, multiple regions, where the people speak different languages. So, if you have a translation system, AI system, which can translate one language to other language, or the regional language into your language that you can understand or communicate, that is very useful application for society, right. If you have a telemedicine system where you can say healthcare system, AI enabled healthcare system, you have a symptom, you just give your face to the system, your model is able to tell you that what type of problem you might have, you are suffering from. You can come up with some primary medication. It can locate you to the nearest hospital, nearest laboratories where you can do the diagnosis. So those things is for the welfare of the humans, welfare of the society. So we have to, lot of things are basically we have to do in that direction. The journey is just started, by the way, you can say, right. We have to do a lot more for the society, right. So these are the current application. First one is the neural network, you know, right now. So this is the generative model, basically, which can generate the model, generate the data, right. Then this is the modern transformer architecture. So transformer is the backbone of GPT, Gemini, DeepSeek. So any LLM that we are using nowadays. So only the last one, you can say, last model is the building block. So we have around 175 transformer modules, transformer layers in GPT-3 version, and the 4th version has many more. Google Gemini has similar to like around 200 or something such layers, transformer layers. DeepSeek has not released its blueprint, not anything, but I am sure that they might have used hundreds of these layers, right. Maybe in coming days you might get the story that what they have used, because they have a model in open source, so it might take few time to basically get stabilized, right. So we will see that how many layers they have used. This is the basically models we have we will learn during this sessions, what are the linear models, what are the non-linear models. So linear models, when we talk about, so we talk about the in mathematics, or you can say in vector space, you can say if any plane is there, right, you can say or line is there, so line is a linear model, right. If you have a plane, you have a straight planes, for example, in 3 dimensions, x, y, z coordinate, you can say that ax plus by plus cz plus some bias is there, you can say d equal to 0. So it means you have a linear plane in 3 dimensions. Likewise, in linear plane in higher dimension, we call it hyperplane, linear hyperplane, right. So you might have a non-linear hyperplane, you can have a different shapes, right. So if your model aligns, so generally in AI we have a hypothesis. So whenever I say that we want to solve a certain problem, learning problem, optimization is another thing. We said that you can do searching, for example, game problem we said here. So those were searching. So we are searching for the solution which is efficient, we call them searching problems. Then you have constraint satisfaction problems, we are searching the solution but given certain constraint. Then we said that okay, given many solutions to satisfy the constraint, we want best solution. Now this comes under that one, COP, right. So we have to first hypothesize the things. So we have to assume that this particular data fits certain type of models, either linear or non-linear. If you say non-linear, then what type of nonlinearity you want in the model. So you might remember in schools, right. So when you are in 11th and 12th, you might have studied the curve fitting, and if you have not heard, you have not studied, you might have heard in the your UG first year math courses. So curve fitting. So you are given a data, so you are given a vector, you have to say that which shape it follows, whether it is sinusoidal, whether it is logarithmic, whether it is exponential, right, or it is mix of these. So first thing is that in order to solve them, you have to assume certain functions, right. Then on those functions you have certain parameters. The task is that you just get the whatever assumption you have made, you just get the output giving the input, then compare the original output that you have. Maybe you can just minimize the squared error or absolute error or some form of loss, some form of basically error you just try to minimize. You will get a fit, you can get the parameter values which basically best fit your data. So that we have done it, and least square algorithm was a very popular algorithm you might have used. So that is the linear regression, by the way, we will discuss maybe later on. And nonlinear is basically some nonlinearity is there. You can see here what are the linear nonlinear model in higher dimensions, right. Then of course, we say that okay, nowadays explainability people ask that why your model works. You have to see, you have to tell everything, so why your model is working. But at the same time, there is challenge of this security challenge. If someone knows that why your model is working, right, you can design attack for that. If it is purely black box, you do not know how and why your model is working, then you are little secure, right. But once you say that why given an email, our model is able to say that this is spam or ham, because certain keywords you say that the weightage of those keywords is high in spam email and weightage of certain keywords is high in ham or original, or you can say legitimate emails. Based on that, we are giving the decision. If your model is saying, tells your client that because of this reason we are giving this solution, then we will very easily try to fool the model, we will very easily try to come up with the adversarial example which can attack your system. We will slightly change the input and we will see that your model will classify, will filter it as a ham email or legitimate email. Then I flood that email, right, on the group, or you can say on the web. So everyone, so it will go to your inbox. So what is the harm, by the way? You said that okay, if we are getting emails, any email in my inbox, so what is the harm? The harm is that suppose you click on the email, certain executables are there. Suppose you have clicked it, then some malware will be installed on your system, malicious software will be installed on your system, and it might do very harm to your system. So the way was, all these basically in companies like Google, Gmail you have, right. So you might have email on Yahoo and others. So they designed their spam system, spam filters. So even as a human, you can say that okay, these type of emails are spam for me. You just put certain tags there. So whenever mail arrive to your inbox, so it is filtered to the spam, and many times your legitimate email goes to the spam, right. So the problem is again challenging, right. So we have many solutions. You can write a very simple code for that, 2-3 line, 4 line code, but even research is there, because we are not able to identify many emails as a spam email even nowadays, right. And many legitimate emails, ham email basically goes to the spam, and we generally missed those emails, right, timely. So that is the challenge. So we have to come up with a filter, and that may harm. So maybe that is a space, of course your storage is there, right. Another one is basically it can contain malicious intentions, malicious information, malicious communication, malicious information. Maybe they say that okay, you have won these many pounds, or some type of mails coming, right. They are saying that I am this person, I got maybe some family members got accident, we have certain money in this certain bank account, because you are a very generous person in India, so I want to basically give that money to you to start business with us, something like that. Please share your contact information. What is your name? What is your organization? Maybe many times they ask, once you start communication, they will ask account information, date of birth, right. So these things. So because the way password we generally, as a human, we generally generate the password is very predictable. So generally we put our kid's name, spouse name, parents name, relative names, or some popular places, some regional names, devotional names, few digits, so that we should remember it, because many times you have to enter password, right, when you want to log in. So we generally use those passwords which can be memorizable, you can remember very easily. So that pattern is known to everyone, so every attacker knows. So they try to get that information from you. So based on that information, because exhaustive search is very infeasible task, right. So they try to build the password, they try to come up with the password. If they are able to get access to your system, right, logins, your banking system or some system. So, they can put any harm. If they are able to log in your social media profile, right, so they can put a lot of losses to you, right. So, these are challenging things. So, that we will discuss here. So, how can we protect, how can we develop a model which people cannot attack on that one, right. So, that is a very simple one. We said here we try to see linear and non-linear. Meantime, linear relationship is not there. So, we want to come up with a non-linear relationship among the features, right, and build the boundaries or build the model. And this slide I have copied from Brainy code, right. So, this was very simplest thing. So, explain it basically says the explainability, right. So, the art of simplicity is a puzzle of complexity, right. I think everyone knows, and we try to basically align our lectures in that direction only, a discussion, because the complex thing we want to understand in a very simple way, right. So, even these models that we have very complex models. So, GPT, Gemini, DeepSeek, these are very complex models, people say, right. So, we want to understand those models very easily in a simple way, right. So, that is a challenge, by the way. So, how I will do it, or how we basically try to discuss. Of course, your help is needed in this. So, the art of simplicity is a puzzle of complexity. So, this basically gives the concept about the explainability. So, can you explain the complex models, why the model is working, why the model gave you this answer. So, one of the development that DeepSeek has and even Google Gemini has, the evidence. So, suppose a teacher is teaching in the class. So, if a student asks the question, maybe suppose a student asks the question, how can you say that this is correct? Either you can do the proof at that time, or maybe some student asks the question that from where you got the evidence, so where is the reference? So, you have to give the reference. If reference is good, renowned, right. So, people will rely on that, right, will have a trust on that, otherwise not, right. So, evidence based solutions, evidence based responses generally Google Gemini gives, because you can say that Google search engine already giving the lot of you can say sites, right. So, you can say the pop-up it gives. So, Google Gemini easily basically put in their basically encoder model that part. So, whenever they give any response, they give certain references, and that style is Wikipedia style. So, I think everyone knows Wikipedia. So, whatever content in Wikipedia you will get, so it is supported by certain references. In ChatGPT we do not have that, but now you can say that the recent versions, we just ask that whatever information you are giving, please give me the evidence. So, it also tries to basically provide you the references. So, based on the venue of the references, you have to, is there any, okay. Someone say, what is the time, by the way? I think it is some automatic. Oh, that is why I think some alarm is there. Okay. So, these are some applications. We will share these slides. So, you can go and you can see the what is the current state of art in this, right, and we will do some experimentation in today's session, right. So, the basic data crawling and some simple spam classification system we will try to build, and we will do little data pre-processing today, right. So, thank you everyone. So, we will meet in the next session. So, we are stopping here.